Now give the next heading basic example 1. Everyone give the next heading basic example 1 and try to write down this question. Everyone first of all give the heading basic example 1. Give this heading basic example 1 and try to write down this question. And after writing of the question, try to read the question. Try to read this question minimum 2 times, everyone. Now I'm going to read the question for you guys. What they are saying in the question. See, what we have to find out here. We have to find out state of H2O. So first target is what? Determine the state of H2O. If its pressure is what? 1 bar and temperature is. So here pressure is what? 1 bar. And temperature is how much? Temperature is 50 degrees Celsius. So before going further, I am going to start writing down the given things. What they have given us here. So for H2O, what is pressure they have given us? For H2O, what is pressure they have given us? Pressure they have given us is what? 1 bar. And temperature, how much they have given us? Temperature is what? 50 degrees Celsius. And for this situation, what we have to find out? We have to find out its state. What we have to find out? State. What is the meaning of state, guys? What is the meaning of word state? See this one. First of all, see this one. What are the different state we have seen? This is the basic example that we have discussed, guys. This is the basic example. Let me minimize little bit. So now, guys, see. These are the 5 states that we are going to deal with here, property table. See, first state is subcooled liquid. Second state is saturated liquid. Third state is what? Liquid vapor mixture. Third is what? Dry saturated vapor. Fifth one is what? Superheated vapor. These are the 5 states we have studied. So in this question, what they have given us? We have a H2O. What we have? Here we have what? A H2O. And for that H2O, they have given us a pressure of what? 1 bar. And temperature of what? 50 degrees Celsius. And for this condition, we have to find out what? Its state. And what are the states? Out of these 5 states. Out of these 5 states, which state will be there for the current situation of H2. And for that purpose, what we are going to do, we will go to the property table. So here we have a property table. This is what our standard property table. Just have a look here. This is what our standard property table that they will give us in exam. The same property table they are going to give us in exam. If possible, take the printout of this property table. If you have a printout of this property table, then it will be very useful for you. So this is the first table. Saturated water stream. Here first column is what? Temperature and corresponding saturation table. So we will go to the second table. And if you go to the second table, where first column is what? Pressure. And its TS means what? Its corresponding saturation temperature. Have a look here. So if you observe here, we have what? Which pressure here we have? Observe. Which pressure here we have? Let me zoom little bit. So here pressure is what? 1 bar. And its corresponding saturation temperature is how much? 99.6 degrees Celsius. See, I am going once again. First column pressure. Second column TS means what? Saturation temperature. What is the meaning of word TS? TS stand for what? Saturation temperature. So if pressure is what? 1 bar. Then corresponding saturation temperature is what? 99.6 degrees Celsius. So see this one. Second table where first column is what? Pressure. Huh? In first table, temperature corresponding saturation pressure. But in second table, pressure and corresponding saturation temperature. So if pressure is what? So from property table, what we will say? For what? Tsat at what? Saturation temperature. At what pressure? 1 bar. Will be how much? Tsat at 1 bar. 99.6 degrees Celsius. See the scenario here. So whenever we have a saturation temperature, means for 1 bar pressure, saturation temperature is how much? 99.6 degrees Celsius. And we have studied already what is meant by saturation temperature. Saturation temperature means what? At a given pressure, temperature at which liquid changes to vapor or vice versa. And we have seen some example also. Here we have seen example of, so see here example 1 bar means For 1 bar, saturation temperature is what? 99.6 degrees Celsius. So I am coming back to the question. So now from property table we come to know that this is the property of that particular liquid. And if you remember our discussion, if our temperature, just see the discussion of subcooled liquid. If our temperature, see this one. If temperature below the saturation temperature, see, for the subcooled liquid, what are the conditions we should have? Our temperature should be below the saturation temperature. And if you see this discussion of the question, what is this temperature? This temperature of 50 degrees Celsius is below the what? So what we can say? Since our temperature is what? Since what we can say? Since temperature is less than what? Saturation temperature. The state of H2O is what? What we can say? The state of H2O is what? The state of H2O. H2O means what? What is the meaning of H2O? Water. Or means chemical name for the water is what? H2O. So the state of H2O is what? Subcooled liquid. Always remember these things. Whenever our temperature less than saturation temperature, whenever our temperature is what? Less than saturation temperature, then the state of that particular substance will be what? Subcooled liquid. And in this scenario, which substance we are dealing with? We are dealing with what? H2O in this case. So here, since our temperature is less than saturation temperature, the state of H2O is what? Subcooled liquid. Now what is our next target? Here we have to find out enthalpy and entropy of that H2O. Now if you remember our discussion, for the subcooled liquid, I have given to you note. Property table of subcooled liquid is not easily available. Hence we consider properties of saturated liquid as properties of subcooled liquid at a given temperature. Means if you want to find out what? Just 1 minute. I will give you one important point here. Means we have written that one. If you remember our discussion, what we have written? Properties of subcooled liquid equal to what? What we have written? See your notes. Properties of subcooled liquid will be equal to what? Properties of saturated liquid. Properties of what? Saturated liquid at a what? At a given temperature. Not at what? Given pressure. So it means what? Suppose if you want enthalpy of saturated liquid, then it will be what? Enthalpy of saturated liquid at what? Given temperature. Suppose if you want entropy of saturated liquid, if you need an enthalpy of subcooled liquid, sorry guys, my mistake. If you need an enthalpy of subcooled liquid, if you need an enthalpy of what? Subcooled liquid guys, then it will be equal to what? Enthalpy of saturated liquid. F stand for what? Saturated liquid property. Enthalpy of saturated liquid at a given temperature. If you need a entropy of subcooled liquid, if you need a what? Entropy of what? Subcooled liquid, then it will be equal to what? Entropy of saturated liquid at a given temperature. So these are the things we have seen. Always remember this point. So whenever we need a what? Enthalpy of what? Whenever we need a what? Enthalpy of subcooled liquid, it will be equal to what? Enthalpy of saturated liquid at a given temperature, not at given pressure. Remember this point, not at given pressure. And whenever we need an entropy of what? Subcooled liquid, then it will be equal to what? Entropy of saturated liquid at given temperature. So, and we are going to use that same property here in this question. So we need a what? We need an enthalpy. And how to get an enthalpy of this subcooled liquid condition? So H will be equal to what? HF at what temperature we have here? What is the temperature of H2O? Here they have given us in the question. Temperature is 50 degrees Celsius. So HF at 50 degrees Celsius. And if you go to the property table, HF at 50 degrees Celsius will be equal to what? If you go to the property table, just go to the property table. HF at 50 degrees Celsius. The first table where temperature First column is what? Temperature. So we will go to the first table, guys. The first table of that property table, 50 degrees Celsius. So here 50 degrees Celsius and corresponding HF. See this one. This column is of what? HF. So this column is of HF and 50 degrees Celsius. For that 50 degrees Celsius is what? 209.3. Suppose I'm little bit zoom out so that you will get an idea properly. See HF, this one, 209.3 unit kilojoule per kg. Just observe. And now I am zoom in. So here 50 degrees Celsius, 209.3. So what we will have, what? H will be equal to what? 209.3 kilojoule per kg. This is what our one answer. So we got what? Enthalpy. Similarly, we can get what? We can find out what? Entropy also. S is equal to what? SF. At what temperature we have? 50 degrees Celsius. See the scenario here. And that will be equal to what? We will go to the again property table. Just observe. So temperature corresponding SF. See this column. See this column. So this column. So 50 degrees Celsius corresponding SF will be equal to what? Corresponding SF will be equal to what? 0.704. So what we can say? 0.704 unit will be what? Kilojoule per kg Kelvin. So that is what our next answer. So we got it what? We got it state, we got it enthalpy, and we got it entropy. So before going further, everyone please write down this discussion. After we have already written the question, this basic example 1. After that, write down this discussion. Now after this discussion, what are they asking us here? See this question. If the state is what? Subcooled liquid, then find out the degree of subcooling. And if the state is superheated vapor, then find out the degree of superheat. See this one. If the state is superheated vapor, then find out degree of superheat. See the scenario here. So now what is the state here? Here our state is what? What is our state here? Subcooled liquid. What is the state? Subcooled liquid. And for the subcooled liquid scenario, what we have to calculate here? What we have to find out? We have to find out degree of what? Degree of subcooling. And what is the relation of degree of subcooling we studied? Degree of subcooling is equal to what? Can anyone tell me? So degree of subcooling will be equal to what, guys? Go to your notes and try to find out what is the relation of degree of subcooling we have seen. What is the relation of degree of subcooling, guys? Everyone. Okay. So T minus what? T sat. Or I am writing, or it is in opposite way. So it will be what? Degree of subcooling will be equal to what, guys? T sat, saturation temperature, minus temperature. And how much saturation temperature here we have? Saturation temperature is what? 99.6. See, it is a property, guys. So 99.6 degrees Celsius. And the temperature is what? 50 degrees Celsius. How much temperature we have? Temperature is what? 50 degrees Celsius. So what will be the value of degree of subcooling, guys? Everyone do the calculation. Degree of subcooling will be equal to what? 99.6 minus 50. So it will become what? 49.6 degrees Celsius. As it is a difference of temperature, guys. As it is a difference of temperature, we can write down degree of subcooling in degrees Celsius also. Or in Kelvin also. We can say 49.6 Kelvin. Now you will say how we got it 49.6. How this degree Celsius and Kelvin will be same? Because it is a difference. And how it is the same? 1 minute, guys. For your reference, I am writing down. Just imagine that. 99.6 degrees Celsius means how much Kelvin? We will add 273. Minus 50 degrees Celsius means how much Kelvin? 50 plus 273. And if you rearrange it, 99.6 plus 273 minus 50 minus 273. So what will happen? 273 cancel out, and at the end you will get a what? Same answer, that is what? 49.6 Kelvin. So whenever we have a difference, in case of difference, we can write down in terms of degree Celsius also, in terms of Kelvin also. Remember my point, because after this chapter we are going to study, there is one chapter, heat transfer, there we need a difference only. So in that case, we are using degree Celsius only. So whenever we have a difference, always remember that you can write unit in degree Celsius or you can write unit in Kelvin. Both are the same thing. You will get the same value. And why you will get the same value? Because 273 will get cancelled out. At the end, degree Celsius minus degree Celsius, we will get a degree Celsius. So getting my point? So whenever we have a difference, you can write down the unit in degree Celsius or Kelvin. Both will be the same thing. You can write down unit in degree Celsius or you can write down unit in Kelvin. Same will be same thing. So before going further, please everyone write down this discussion, guys. Everyone give the next heading basic example 2. Everyone give the next heading basic example 2 and write down this question, guys, everyone. And after writing down this question, try to read this question minimum 2 times. Now what this question want to say, we are going to understand. What this question want to say, we are going to understand now, guys, everyone. See, here we have what? H2O, guys. Here we have what? H2O. H2O in liquid form, we call it as a water. H2O in vapor form, we call it as a steam. So now, we have what? What is the pressure of H2O? We have the pressure of H2O is what? 10 bar. And here they have given us a what? So pressure is what? 10 bar. And how much enthalpy they have given us? What? 2060 kilojoule per kg. So enthalpy is what? 2060 kilojoule per kg. If you remember our discussion, from these drawings, there I have given you, see, if you remember our discussion, see, there I have given you a few important points related with this TS diagram, or I will say, instead of that, I will write down here only. Okay, see guys, so before going further, whenever we have a such type of scenario, whenever we have enthalpy and whenever we have a pressure, what we are going to do, we are going to find out enthalpy of saturated liquid, means HF, at what? 10 bar. We will go to the property table and we are going to find out what? HF at 10 bar. So we will go to the property table and HF at 10 bar. 10 bar, where we have to see the table in which first column must be what? The table in which first column must be what? Pressure column. So here column is what? Pressure. Okay. But is it here we have 10 bar? No, up to 1 bar. So see the third table. So pressure bar, 1 bar, and so we got it 10 bar here. So we got it 10 bar. Observe here, pressure 10 bar and corresponding value of HF. So this one, let me zoom out. So 10 bar, see this one. So here we have what? 10 bar and corresponding value of HF, guys. Observe here, corresponding value of HF. See this one. See this one. If you observe here, this is 10 bar, corresponding value of HF. How much we have? 763 unit kilojoule per kg. So corresponding value of HF 763 unit kilojoule per kg. And then the next thing, what we are going to find out from the property table? Next thing we are going to find out Hg at what? 10 bar. So we will go to the property table again and Hg at 10 bar. So say this one same. Hg at, let me zoom little bit so that, okay, little bit. Now it is okay. So Hg, see this one, 10 bar, see this one, this. And here see this corresponding Hg, this value. So this value visible to everyone. So this value will be what? 2778. So we got it what? What is the value of Hg at 10 bar we are getting? 2778. Unit will be what? Kilojoule per kg. Now if you remember our discussion for the weight vapor, what we studied for the weight vapor, guys? For the weight vapor, conditions for the weight vapor we have studied. Means our V less than Vg, H is greater than HF and less than Hg. See this condition. So here this condition is satisfying. How it is satisfying? The given value of enthalpy in this question, the given value of enthalpy is what? H 2060 is lies between this HF and Hg values. This HF and Hg values. So what we can say? Since H less than Hg value, guys, see how I am writing? H suffix G, guys. Suffix means bottom. And this H is what? Greater than what? HF. So what we can say? The state of H2 is what? The state of H2 is what? Weight vapor. So we got it first part answer, A part answer. So in A part what they are asking us? They are asking us what? State of the H2O if its pressure is 10 bar. So before going further, so this is what our A part answer. Let me box it. This is what our answer of the A part, guys. So before going further, please everyone write down this discussion. Now in B part what they are asking us? What we have to find out? Degree of superheat if the state is superheated vapor. But here we don't have superheated vapor. What we have? Dryness. What we have? So what is the next here? Dryness fraction if the state is weight vapor. So what we have to find out in B part? We have to find out in B part. Our target is what? We have to find out X. Dryness fraction means what? X. And how to get the value of X in B part? Try to see the scenario here. We know this relation. We have seen relations of the properties of weight vapor. Which relations we have seen? See these three relations we have seen. Observe these three relations. First one specific volume, second one enthalpy, third one entropy. So these are the three relations we have seen. So I am going to use the second relation because we have enthalpy. So the second relation I am going to use. So now what is the second relation we have seen related with enthalpy? So H will be equal to what? HF plus X into what? Hg minus HF. So X will become what? H minus HF divided by what? Hg minus HF. Now I am going to substitute all the values, whatever the values we have, guys. Everyone try to see the scenario. How much value of enthalpy we have, guys? Tell me the value of enthalpy we have. We have the value of enthalpy is what? 2060. We have enthalpy is what? 2060. HF value we have what? 763. Then Hg value is what? 2778 minus 763 HF value. So please everyone do the calculation and then we will get a value of dryness fraction. That is what they are asking us in the B part, guys, of this question. So please everyone put these things in your calculator. Always do the calculation with me, guys. So 2060 minus 763 divided by what? 2778 minus 763. So if you do the calculation, what is the value of dryness fraction? Guys, we are getting everyone 0.64. Everyone do the calculation. So if you do the calculation, guys, we will get the value of what? 0.6437. So this is the value of dryness fraction, guys. What is the meaning of dryness fraction? It means what? In this proportion, there is what? In that saturated liquid vapor mixture, in that wet vapor, percentage or proportion of vapor, guys. What is the meaning of dryness fraction? Dryness fraction is what? By this proportion, or in terms of percentage, how we will write down? 64.37%. So in proportion 0.6437 of proportion of what? Vapor in that wet vapor, or 64.37 percentage of vapor in the wet vapor, guys, in that wet vapor that we have given to us. So before going further, please everyone write down this B part, guys. Now after this B part, what they are asking us in C part, what we have to calculate? We have to calculate specific volume and entropy, guys. What we calculate in C part? Specific volume. How we denote specific volume? By small v. And what? Second thing is what we have to calculate? Entropy. For that purpose, what we are going to do? First of all, we will go to the property table and we are going to find out Vg at what pressure we have, guys, everyone? Vg at what? 10 bar. So we will go to the property table. Everyone go to the property table and try to find out Vg at 10 bar. So go to the third table, guys, everyone. Go to the third table. See this one. Vg at 10 bar. See this one. This is the column of Vg, guys. See this one. This, have a look at the cursor, guys, everyone. This is the column of Vg and corresponding to pressure 10 bar, guys. This 10 bar. So corresponding to pressure 10 bar. So you will get a what? 0.1944. So value of Vg is what, guys, everyone? Go to the property table. 0.1944 unit. What is the unit, guys, everyone? Specific volume. Specific volume must be in what, guys? Meter cube per kg. So unit is what? 0.1944 meter cube per kg. And if you remember our discussion, guys, specific volume of wet vapor, what relation we will use? X into Vg, guys. Which relation we are going to use? X into Vg. So we are going to use, so specific volume relation will be what? V is equal to what? X into Vg, guys. Don't get confused. See, I am writing X like this and this is the Fermi multiplication symbol, guys. Always throughout the discussion, always remember that this is Fermi X and this is what? A multiplication symbol, guys. So don't get confused. So X into Vg. So X is what? So X value is how much, guys, everyone? We have written 0.6437. Don't take percentage value here. Always take a proportion value. And then the next thing, Vg is how much? 0.1944. So if you do the calculation, guys, how much value of we will get? Specific volume of this wet vapor, 0.6437. Everyone do the calculation with me. 0.6437 multiplied by what, guys, everyone? 0.1944. So if you put these values in your calculator, we will get a what? Specific volume is equal to what? 0.1251 unit. Unit will be what? Meter cube per kg, guys. Never forget the unit. Unit is very, very important in any technical subject, guys. So before going further, please everyone, so we got one part of C, one answer of this C part, guys, that is specific volume. So before going further, please everyone write down this C part, guys, everyone. Before going further, please write down the C part. Now another target of C part is what? What we have to find out? Entropy. And for the getting entropy, we need a what? We need a SF, entropy of saturated liquid, at what? 10 bar, because our pressure is what? 10 bar here. So again we will go to the property table. SF, see, this is SF column and corresponding value of what? At 10 bar, 2.138, guys. Observe 2 point, here this one 2 point. So corresponding to 10 bar, what is the value of SF, guys, everyone? SF value is what? 2.138. What is the value, guys, everyone? 2.138 unit kilojoule per kg Kelvin. And then we are going to find out entropy of saturated liquid, that is SG at 10 bar. So again go to the property table, guys, everyone. SG at 10 bar and SG at 10 bar, guys, everyone, see this one, 6.586. So 6.586 unit kilojoule per kg Kelvin. And what is the relation of entropy we have seen, guys, everyone, for the wet vapor? Go to the relation, third relation we will get. So this one we are going to use SF plus X Sg minus SF. So what we have? Entropy will be equal to what, guys, everyone? S will be equal to what? SF plus what? X into what? Sg minus SF. So we will put all the values. SF value is what? 2.138. X value is what? 0.6437 into in bracket 6.586 minus 2.138. Put these values in your calculator, guys, everyone. Put this in your calculator. Always do the calculation with me, guys. 2.138 plus 0.6437. If you want, you can pause this video and do the calculation, guys. 6.586 minus 2.138, guys. So if you do the calculation, what is the value of S we are getting, guys? 5.0012 unit kilojoule per kg Kelvin. So we got the value of what, everyone? We got the value of what? Entropy, guys. So before going further, please everyone write down this discussion of entropy, guys, everyone. That is what our C part answer. So this is all about basic example 2, guys. Everyone give the next heading basic example 3. Everyone give the next heading basic example 3 and write down this question, guys, everyone. Write down this question after the heading, and after writing down, guys, try to read this question minimum 2 times, guys. Now if you observe, guys, here what we have here. So now I'm going to see this what we have to deal with this question, guys, and how we are going to approach. Here we have a rigid tank, guys. Rigid tank means what? Rigid means what? Whenever they said rigid means fixed one, means its volume of the tank will remain constant, guys. So here we have a rigid tank. Rigid means not movable. Everything is fixed related with that tank. It means volume of that tank is a fixed. So in rigid tank, how much H2O, guys, everyone? Rigid tank contains 10 kg of what? H2O at 90 degrees Celsius. So how much total mass? Total mass of H2O is how much, guys, everyone? 10 kg. At what temperature, guys, everyone? Temperature at what? 90 degrees Celsius, guys. Now if 8 kg of H2O is in liquid form. So here what is the H2O in liquid form, guys? H2O in liquid form is what? 8 kg and remaining in the vapor form. So what will be the mass of vapor of the H2O, guys? Mass of the vapor will be what? M total minus what? M liquid, and it will become what, guys, everyone? 10 minus 8. So it will become what? 2 kg. So mass of vapor is what? 2 kg. Now what we have to find out? We have to find out pressure in the tank. What is our target here? We have to find out pressure in the tank. Now see the scenario here. So here in the tank we have H2O, but that H2O is in what? Liquid and vapor form. Whenever any substance is in liquid vapor form, it means what? Wet vapor. Whenever any liquid is in liquid vapor form, whenever any substance is in liquid vapor form, it means what? It is a wet vapor, guys. Means here we have a liquid 8 kg and vapor 2 kg. So it is meant by what? Wet vapor, guys, everyone. It is meant by what? Wet vapor. So what is the meaning of word wet? Wet means what? In that case liquid is there. So here we have a vapor with a liquid, guys. It means. So here we have a vapor with liquid. It means what? Wet vapor scenario. And whenever we have a what? Wet vapor scenario, guys, everyone. Whenever we have a wet vapor scenario, it means what? Pressure in the tank will be equal to what? Saturation pressure. So as tank contains, guys, observe. As tank contains, what is in the tank, guys? As tank contains wet vapor, guys. As tank contains what? Wet vapor. So pressure in the tank will be equal to what? Saturation pressure. Always remember this point, guys. Whenever tank contains whenever tank contains, guys, everyone, whenever tank contains wet vapor, its pressure will be equal to what? Saturation pressure at what? What is the temperature, guys, everyone? 90 degrees Celsius. So what we will do, guys, everyone, we will go to the property table again, and where first column must be what? Temperature. See this one, first column must be what, guys, everyone? Temperature. And for temperature 90 degrees Celsius will be what? Corresponding Psat, guys, everyone, for 90 degrees Celsius. So pressure will be equal to Psat. What we have written? Pressure is equal to saturation pressure at 90 degrees Celsius, because we have what, guys, everyone? What we have here? Wet vapor, guys. What we have? Here we have what? Wet vapor. So again I'm going to the property table, and 90 degrees Celsius, guys. See, temperature corresponding saturation pressure. First temperature column, second saturation, guys. So 90 degrees Celsius corresponding saturation pressure is what? 0.7011, guys. So how much pressure we are getting? Pressure in the tank? 0.7011 bar, guys. So before going further, please write down this discussion, guys, everyone. Please write down this discussion. Now after that, what is our next target? What we have to find out? We have to find out volume of the tank, guys. What we have to calculate? What we have to determine? Volume of the tank. And how to get the volume of the tank? Very simple discussion, guys, not that much difficult. So first of all, we are going to calculate what? Dryness fraction. What is the basic relation of dryness fraction, guys? Mass of vapor divided by what? M total. Mass of vapor is what? 2 kg. M total is what? 10 kg. And so dryness fraction will become what? 0.2. Now we will go to the property table again, and we are going to find out what? Vg at what? 90 degrees Celsius. Specific volume of saturated liquid at 90 degrees Celsius. So again I am going to property table, Vg, guys. And which column of the Vg, guys? The third column. So for 90 degrees Celsius. So 90 degrees Celsius, third column. It will be how much, guys? Everyone tell me. For 90 degrees Celsius, 2.361, guys. How much? See this one. 90 degrees Celsius, first temperature column, third Vg column. So Vg at 90 degrees Celsius. How much, guys, everyone? 2. How much? 2.361. So 2.361 unit will be what? Meter cube per kg, guys. So we got it what? Vg at 90 degrees Celsius. Then so we got it value of Vg. Now then specific volume of wet vapor, guys, everyone. What is the relation of specific volume of wet vapor? We have seen specific volume of what, everyone? Specific volume of wet vapor, and that will be equal to what? V is equal to what? Small v I am writing, x Vg, x into Vg, guys. This is into, and x is how much? 0.2. Vg is how much? 2.361. So if you do the calculation, guys, how much value of we will get specific volume, guys? 0.2 multiplied by what? 2.361. So 0.4722. And always, guys, see, sometimes now for us small v and capital V will write down the similar. So it will be always confusion for us. Oh, what is it? Volume or a specific volume? And how does we come to know that it is a specific volume? We will write down the unit properly. Meter cube per kg, guys. So always, whenever possible, guys, means always, guys, not whenever possible, always write down the units, guys. So we got it specific volume. And if you remember, what is the relation of specific volume, guys? What is the basic relation of specific volume? Specific volume will be equal to what? Volume per unit mass. We have studied, guys, here. So specific volume is equal to what? We studied these things in our chapter 1 also, and in this refrigeration chapters also in the beginning. So specific volume will be equal to what? Volume divided by what? Mass. And our target is what? We have to find out volume. So volume will be equal to what? Volume will be equal to what? We can say specific volume multiplied by what, guys, everyone? Mass. Specific volume means what? Small v. So So volume will be, so how much specific volume we got it, guys, everyone? So capital V is equal to what? Small v into m. So how much specific volume we got it? 0.4722 multiplied by mass is how much? See, here we are calculating volume of the tank. So we have to consider total mass of the tank, na guys, everyone. So we calculated average specific volume, we can say it like that. So, and mass is what? 10 kg. So volume of the tank will become what? 4.722. As it is a volume, we should write down only meter cube, guys, not meter cube per kg. Meter cube per kg is for what, everyone? Specific volume, guys, and they are asking us only volume in this question. So before going further, please everyone write down this discussion, guys, of this question, because here they are asking us volume of the tank. So please everyone write down this discussion. Now after this one, guys, what we have to do? Write down this remaining also. Everyone write down this remaining also. So this is all about basic example 3, guys. Now we are going to see basic example 4, guys, everyone. Now what we are going to see? Basic example 4. So before going further, please everyone give the heading basic example 4 and write down this question, guys. After writing down this question, try to read this question minimum 2 times, guys. Now what we have to do in this question, guys? Observe the scenario here. Very simple discussion, not that much difficult discussion, guys. See what we have here. As usual, here we are currently dealing with H2O, guys, because H2O is easy to understand. That's why we are discussing the things related with H2O. So we have H2O whose pressure is how much? 0.5 bar, and temperature is what? 250 degrees Celsius. So I am writing down the given things. So pressure is how much? 0.5 bar, and temperature is what, guys, everyone? 250 degrees Celsius. So now if you see this one, guys, everyone, pressure 0.5 bar, temperature is what? 250 degrees Celsius. So what will be the scenario, guys, everyone? So now we will go to the property table and we will try to find out what? Saturation temperature at what? 0.5 bar, guys. Everyone go to the property table and try to get a what? Saturation temperature at 0.5 bar. So for that purpose, what we have to go to? So first table temperature, no, we don't want. Second table pressure, yes, this we want. And here what? 0.5 guys, see here 0.05 also, but we want 0.5. 0.5, where we have a 0.5, guys, everyone, decimal 5. So this is what? A 0.5, guys, and corresponding saturation. See, pressure, and first column is what? Pressure, second column is what? Saturation, guys. So 0.5 corresponding to 0.5 is how much saturation temperature we have, guys? Can anyone tell me? This one, guys, everyone, second column, saturation. So what is we have? 81.3 degrees Celsius. So if we write down here 81.3 degrees Celsius. And now if you remember our discussion related with superheated vapor, guys, everyone, for superheated vapor, always remember that temperature must be greater than saturation temperature. If this condition satisfy, guys, automatically remaining condition will also satisfied. So it means what, everyone? It means what? Always remember this point. So since what they are asking us, firstly, state of the H2O, guys. Since what we can say? Since temperature of H2O greater than the saturation temperature, guys, everyone, what we can say? Since temperature is greater than the saturation temperature, the state of H2O, the state of what, guys, everyone? The state of H2O is what, everyone? Superheated vapor, guys. Getting my point? So whatever theory we discuss, that theory should be in your mind. Then each and everything in the refrigeration tab chapter will become very, very easy, guys. So before going further, everyone, please write down this discussion. Now the next thing is what we have to find out. Also find out degree of superheat if the state is superheated vapor, or degree of subcooling if the state is what? Subcooled liquid. So now tell me which state here we have? Superheated vapor or subcooled liquid, guys? Everyone. The state with us here we have what, guys? Everyone? Superheated vapor. Which state we have here? Superheated vapor. And for superheated vapor, they are asking us degree of superheat. And if you remember our discussion of degree of superheat, guys, everyone, go to the superheated vapor. So degree of superheat relation, what we have seen, guys? T minus T sat, guys. What is the relation of degree of superheat we have seen? Degree of superheat relation we have seen T minus T sat. So I will write down degree of superheat will be equal to what, guys? Everyone? Degree of superheat will be equal to what? Temperature minus what? Saturation temperature, guys. And how much temperature we have? 250. Corresponding saturation temperature for 0.5 bar is what? 81.3. So if you do the calculation, guys, everyone, put these values in your calculator and tell me the value of degree of superheat, guys. Everyone. And if you do this calculation, please everyone put this value in your calculator. So if you do the calculation, we will get a what? Degree of superheat 168.7 unit, guys. Everyone, I told you, whenever we have a difference of two temperatures, you can write down unit degree Celsius or Kelvin. So we can say degree of superheat 168.7 Kelvin, or we can say 168.7 degrees Celsius, because it is a difference, guys. And whenever we have a difference, we already discussed, we can write down unit in Kelvin also and in degree Celsius also. Both are the valid things, guys, everyone. So before going further, please everyone write down this discussion, guys. Till now we have seen what? Up to this point, guys, everyone, we got it what? Degree of superheat. Now what they are asking us next? Enthalpy and entropy. What they are asking us next? What we have to find out? We have to find out enthalpy and entropy. And see, here we got it what? Superheated, guys. So before going further, I will give you just a brief introduction of the tables related with H2O, guys. Here there are a lot of tables of H2O, but we need a what? Following 7 tables of H2O. See, guys, which tables of H2O we needed here? Always remember this point. See, there we have total 7 tables, guys. I will write down first table one by one. So first I will divide that one into 3 parts. First, second and third, guys. See, first related with the temperature. First related with the temperature and corresponding PSAT here we will get. Here this table is only one table here in the property table, guys, and that is the first one. Observe here. 1 minute, I will go to the first page, means first table. So this one, temperature, corresponding saturation pressure and corresponding values we will get from this first table. Now if you observe here, guys, 1 minute, then second table, guys, pressure, saturation temperature. See, second one. Third one, pressure, saturation temperature. And third one, fourth one, pressure and saturation temperature. Means what? If you observe from here, guys, from this one, pressure, saturation, first one, pressure, saturation, second one, and third one, pressure, saturation. So for this one, we have a total 3 tables, guys. Everyone, what we have? Total 3 tables. So pressure, corresponding Tsat, guys. And how many tables we have? 3 tables. So till now we have seen 4 tables. And at the end, guys, everyone, what we have? See, after this one, guys, after the third table of the pressure table, we will have what? Superheated steam, guys. Superheated steam. So it starts from the pressure 0 bar. Then second table of the superheated steam 5 bar. And third table start with what? Superheated steam 80 bar. And don't worry about the supercritical steam. It is out of scope for us, guys. Supercritical steam is a different scenario that is out of scope. So if you observe here, guys, everyone. So for superheated steam, guys, how many table with us? Total 3 table. First start with 0 bar, second start with 5 bar, and third start with what guys everyone? 80 bar. So we have what total how many tables related with superheated steam? A table related with superheated steam guys everyone. What we have? Superheated steam is what? Or superheated steam means what? Superheated vapor guys. Huh? Superheated steam means what? Superheated vapor. And how many table? 3 table. So total 7 table related with H2O is important to us. After that we have a few tables of what we can say. After that we have what? This mercury is not important to us. Ammonia is also important. See which tables are important to us. So this one, first of all, temperature, saturation, that first table, one table. This one we have a 3 table, superheated steam, 3 tables. And then fourth table which is important to us, what? Ammonia. See this one, ammonia guys everyone. This is a table related with ammonia. And then next table which is important to what? Difluoromethane guys everyone. This is refrigerant 12 and refrigerant 12 means nothing but R12 guys. So the next table that is important to us, what? The fifth one is what? The important table is what? R12. Here we have only one table related with this one. Here also one table related with this one. Then sixth and last one which is important to us guys everyone. The last one which is important to us guys everyone, that is R134A, tetrafluoroethane guys, which is important one? Tetrafluoroethane, R134 means refrigerant R134A. So we will write down in short form R134. In exam also they will give you R134A like that. So R134A. So the last table is what? R134A, and it is what? One table guys everyone. So these are the few important table with us guys. If possible, take a snapshot of this one guys. That table related, we will say important tables. This is for the H2O guys everyone. This is again for the H2O. This is also again for the third one, also for the H2O. This is for the ammonia. So these are the few important tables for us guys everyone. These are the tables we need. Currently we are dealing with only these 7 tables guys, 7 tables of H2O. But when we start refrigeration guys, we need ammonia, R12 and R134A. And R12 means what? If you go to the property table, R12 means what? Refrigerant 12 guys. R12 means what? Refrigerant 12. So sometimes in question, in exam, where is the table of R12? They will give us, which refrigerant we are going to use in refrigeration system. We are going to use what? R12 guys. So initially you may feel these things little bit difficult, but if you practice the numericals guys, then you will get all the things, all the things will get smooth guys. So don't worry, have some patience. All the things will get clear step by step guys. So now we have seen, till now we have seen these 4 tables guys. Now we are going to deal with what? Superheated vapor table. Now I'm again coming back to the question. So we have already written up to this point guys everyone. Check it. Yes, we have already written. So if you are not written guys, please write down. Now what they are asking us in the question, they are asking us what? Enthalpy and entropy guys everyone. What they are asking us in the next part? Enthalpy and entropy. And what is the state of H2O here? The state of H2O is what? Superheated vapor. What is the state guys everyone? We have a state is what? Superheated vapor guys. Observe here. State is what? Superheated vapor. And for superheated vapor guys, we have seen for the H2O we have what? 3 table. So I'm going to again coming back to this discussion guys everyone. So superheated guys, we need a what? Superheated. So superheated, here it is starting. So what is pressure we have guys everyone in this question? Pressure is what? 0.5 bar. So I'm going to the 0.5 bar. So 0 bar, 0.01, 0.001 means 0.05. So see this one, we don't want 0.05. We want 0.5 guys. So for 0.5 bar, they have given us a value of Vg, UG, HG, SG guys. See this one, I'm little bit zooming. For 0.5 bar, they have given us what? Different values, guys. 0.5 bar, UG, VG, UG, HG, SG. And then from here, these are related with saturated liquid properties, guys. Here they will give us saturated liquid properties also. But superheated properties starts from here, guys. Specific volume, internal energy. We don't need internal energy, guys. That is not that much important for us. The next is what? Enthalpy. And next is what? This is entropy of the superheated vapor. So, see, these things are related with what? Saturated vapor, guys. These things is related with what? Dry saturated vapor. But here, this one, from this side, guys, this side, right hand side of this column, guys, right hand side of this column is entirely related with superheated vapor. So, don't get confused. Oh, sir, this is the property of VG. No, this is VG, guys, everyone. And this is related with specific volume of superheated vapor. This one. All these are specific volume of superheated vapor per different temperature, means for the 100 degrees Celsius, for the 150, 200, 250, like that, guys. So we need a what? So we will go to the question. And what we need, guys, everyone, we need a what? Enthalpy. At what pressure? 0.5 bar. And what temperature? 250 degrees Celsius. So pressure is what, everyone? What is the pressure we have? So we need a enthalpy. Enthalpy at what? H at what? 0.5 bar. And temperature is what? 250 degrees Celsius, guys. Observe. So we will go to the property table. H at 0.5 bar. So H at 0.5 bar, guys, everyone. H. So H will start here. This is a saturated liquid, saturated vapor property, guys. This is saturated vapor, Hg. Superheated vapor property starts from here, guys. So this is for the 100. This is for the 150. See this one. This is for the 200, and we need a for what? 250. So we need a what? Enthalpy at a 250, and enthalpy at 250 is how much, guys, everyone? So enthalpy, this is rho for the enthalpy for the 0.5 bar, and this is how much, guys, everyone? See this one value. Can anyone tell me? For the 250 degrees Celsius, it is what? 2976 kilojoule per kg, guys. It is what? 2976 kilojoule per kg. So we got the value of H, what? 2976 kilojoule per kg. So this is what? One answer, we got it. Now second thing what they are asking us here, entropy also of the superheated vapor. So entropy will be what? S is equal to what? S at what pressure we have? 0.5 bar. See this one, I am checking once again, guys. 0.5 bar and temperature 250 degrees Celsius, guys. So 0.5 bar pressure and temperature 250 degrees Celsius. So yes, guys, this is what a S. What is the meaning of S? Entropy. So entropy will be equal to what? If you see this one, again I am going back. So 0.5 bar, don't see 0.05 bar in hurry. What will happen? We will go to this one, 0.05. But what they are saying? 0.5 bar. So decimal 5. So now 250 degrees Celsius, this one, guys. This is for the saturated vapor, guys, dry saturated vapor. And superheated vapor properties start from these here, guys. These are the properties related with superheated vapor. So see this one, guys. 100. This is for the 150. This is for the 200. And we need it for what? 250 degrees Celsius. And for 250 degrees Celsius, entropy value for the 0.5 bar, 8.355, guys. How much? 8.355 unit kilojoule per kg Kelvin, guys. See here they are asking us just entropy, guys. They have not said specific, but by default, guys, if they have not given us a mass, then if they have not given us a mass and there is no way to calculate mass, then enthalpy and entropy both are the what? Specific entropy. But we will say simply entropy. And how does we come to know that it is a specific entropy? Though we are seeing an entropy, but still it is what? Specific. And how does we come to know that it is a specific? By its unit. This is a, we are saying enthalpy, but actually it is a specific enthalpy. See, we are saying just enthalpy, but actually it is what? Specific enthalpy. And how does we come to know that it is a specific enthalpy? By its unit, guys. From the units, we will come to know that it is a enthalpy, specific enthalpy, or specific entropy by their units, guys. See the units. So here we are saying just enthalpy, but actually it is a specific enthalpy, guys. And how does we come to know that it is specific? By its unit. And here it is not, it is a, here we are saying entropy, but it is not an entropy. It is actually specific entropy. But we are lazy with the saying word specific. We are omitted that word. But how does we come to know that it is a specific entropy, guys? Everyone, we are saying just entropy, but actually it is specific entropy. And how does we come to know that it is a specific entropy? By its unit, guys. Getting my point? Try to understand the scenario. We are discussing very, very important points, guys, here. So here, before going further, please everyone write down this discussion, guys, of enthalpy and entropy. And after this one, if possible, take a snapshot of this one, guys. These are the few tables which are important for us. Temperature to PSAT, H2O table. Pressure to TSAT, H2O. 3 tables are there. Superheated steam, 3 tables for the H2O. Ammonia, 1 table. R12, 1 table. R134, 1 table, guys. So take a snapshot of this one. These tables are important for us, and we have already seen these tables, guys. Now we are going to see. Now here, if you observe here, guys, in this question that we have currently discussed, guys, if you observe in this question, which temperature they have given us? Which temperature they have given us? 250 degrees Celsius. Which temperature they have given us, guys? Everyone, 250 degrees Celsius. But suppose, and that 250 degrees Celsius luckily available for us in the property table, guys. That 250 degrees Celsius luckily available to us in property table. So we got it directly. Oh, we need an enthalpy. Enthalpy at 0.5 bar pressure and corresponding 250 degrees Celsius, 2976. Luckily that 250 degrees Celsius available to us in property table. And just imagine that 250 degrees Celsius is not available to us. Then what will happen, guys? Suppose instead of 250 degrees Celsius, just observe here, guys, everyone, instead of 250 degrees Celsius, I'm going to take a next example, guys, basic example 5. Everyone, don't write down anything here. Just see this one. See this one. Here pressure is what? 0.5 bar and temperature is what? 260 degrees Celsius. And for this one, we have to find out the state. We have to find out enthalpy and entropy, guys. We know the state. State will be by default superheated vapor because temperature is greater than saturation. But here, how to get this enthalpy and entropy for the 260 degrees Celsius? Because in this one, 260 degrees is not available to us. This 260 degree, is it available to us? And here comes to the role of the interpolation, guys. If any value is not available in the property table, in that case, guys, see, getting all the values is not always feasible, guys. It is possible, but it is not feasible, guys, everyone. Calculating means getting all properties at the all values, means all temperature, guys. It is possible, but not feasible. Instead of that, what we are going to use? We are going to use one term, that is the meaning of interpolation, guys. So now what is the meaning of interpolation? So before going further, everyone give the heading interpolation. Just give the heading. Don't draw this figure, guys. Everyone, before going further, give the next heading. Interpolation. Everyone give the next heading. Interpolation. And what is the interpolation, guys? See, how to deal with interpolation? Very simple things. See, there is a one line. This is the line. It is passing through the 3 points, guys. First is what? Point P1. What we will say? This is a point P1. Its coordinate is what? X1, Y1. We know the coordinates meaning of what? We have studied these things. Second point is what? P2. This point, guys, everyone. This point is what? P2. Its coordinate is what? X2, Y2. And third point is what? Point P. Its coordinate is what? XY, guys. So this line is passing through the 3 points P1, P2 and P, guys. Observe. This line is passing through the how many points? 3 points P1, P2 and P. P1 coordinates X1, Y1. P2 coordinates X2, Y2. And P coordinates is what? XY. This is the comma, guys. Comma. This is the comma symbol. So now, and here see, we know the slope of a line, guys, everyone. If you remember discussion, basic discussion of our basic mathematics discussion, guys. What is the relation of slope of line? What is the basic discussion of the slope of line, guys? If you remember our basic discussion of the slope of the line, guys, everyone observe. Slope of a line will be equal to what? Slope of a line will be equal to what, guys, everyone? Slope of the line will be equal to what? Y. I will write down in generalized term. Delta Y minus what? Delta X, guys. It means what? Delta Y means what? If you consider these 2 points, Y minus Y1 divided by what? X minus x1. If we consider p1 and p2, then y2 minus y1 divided by what? X2 minus x1. Observe the scenario, and this is the what? Our relation of interpolation. Y minus y1 divided by what? X minus x1 is equal to what? Y2 minus y1 divided by what? X2 minus x1. And strictly don't use any other relation, guys. Go through this relation, slope of a line, guys. This relation is very helpful in maths also, in mechanics also, in naval architecture also. In naval architecture also there are sums. In mechanics also there are sums. In maths there is an entire topic related with craft. There we need a relation of slope, guys. So don't use any other relations, guys. Strictly stick to this relation, guys. Everyone stick to this relation, guys. Don't use any other relation. So before going further, please everyone, what you have to do? Before going further, guys, everyone, what you have to do? Draw this figure, give this heading. If you are not given the heading, guys, give this heading, interpolation. After this heading, draw this figure properly. This straight line, show the x and y axis properly. Then this straight line. Please everyone, write down this discussion, guys. After this, guys, everyone write down this remaining discussion. Now, how to use a interpolation, guys? Now, how to use a interpolation? Just a simple discussion, guys. Now, how to use a interpolation? See this one. Suppose here we have what? X1, Y1. Means we have all coordinates of point 1. Means just imagine that all coordinates of point 1 is what? 1, 2. Point P1, coordinates of 1, 2. Point P2 coordinates is what, guys, everyone? Point P2 coordinates is what? 4, 5. And for the point P, we need only one coordinate. We know only one coordinate, that is, we know 2, and Y coordinate is unknown to us. Then, what we can do, guys, everyone? We can use this relation of interpolation, guys. We can use this relation of interpolation and we can get the value of y, guys. We can use this relation of interpolation. That is basically, relation of interpolation is nothing but what? Relation of slope of a line. Means how to get that one? See this one, guys. Observe. Here we have what? Guys, if you observe here. So here these are the coordinates of point P1, P2 and point P. So observe this one, guys. See, we are going to use this relation. Just I am giving you just one basic example, guys. No need to write down. Suppose we have a value of y. That is unknown to us. Y is unknown to us. So y minus y1. Y1 is what? 1. And then x. X is how much, guys, here? Value of x is what? 2. 2 minus y1. Sorry. X1. 1 minute, guys, what I am writing. Y minus y1, na? So this is what? X1, y1. X2, y2. This is what? X and y. So y minus y1. Y1 is what? 2. Then x is 2. Y1 is what? I will write down instead of here. I will take it as a 3, guys. Just imagine that I am taking it as a 3. And then corresponding. So here 3 minus y. Check it, guys. 3 minus y. What I am writing? So x minus x1. 3 minus 1. 3 minus 1. And then at the end y2 minus y1. So 5 minus 2. And what? X2 minus x1. 4 minus 1, guys. I am checking y minus y1. Okay, 4 y minus 2. 3 minus 1. And here what we have? What is the next thing? Y2 minus y1. 5 minus 2. 4 minus 1. And if you solve this one, guys, everyone, we will get the value of corresponding y. And same thing we are going to do in the same in this one, guys, the basic example 5. So before going further, everyone. So before going further, everyone give the next heading, basic example 5 guys. Everyone give this heading, basic example 5, and start writing down this discussion guys. Everyone write down this question. Before going further, everyone give this heading and start writing down this question and try to read this question minimum 2 times. Now try to see the scenario here, what we have to do and how we are going to approach. So here, see the scenario guys, very simple discussion, not that much difficult discussion guys. See, our target is what? So what is, we have to find out state of H2. So pressure is what? First of all 0.5 bar, and temperature is what? 260 degrees Celsius, and our target is what? To find out state. And we did similar thing in the last numerical. So what we are going to do, we will go to the proper table and we are going to find out what? Tsat at 0.5 bar. Saturation, temperature at what? 0.5 bar pressure. So we will go to the 0.5 bar, everyone. 0.5 bar. 0.5 bar, 0.5 bar. See this one. Second table guys, everyone. 0.5 bar. Here we have a 0.5 bar guys. This is 0.5 bar and corresponding saturation 81.3. So, see, pressure, saturation, temperature for 0.5 bar, corresponding saturation is what? 81.3. 81.3 degrees Celsius guys. Saturation corresponding saturation temperature for the 0.5 bar is 81.3. So, what we can say, since our temperature is greater than saturation temperature, what will be the state guys, everyone? The state of H2O is what guys? Superheated vapor. What is the state of H2O? State of H2O is what? Superheated vapor. That is what our first answer. That is what they are asking us in the first part of this question guys. So before going further, please everyone write down this discussion guys. So now we got it, state of H2O. Now what is our next target? What we have to find out? Enthalpy. This is enthalpy guys, and entropy. So what we have to find out? Enthalpy and entropy. And here guys, see why we are taking this question. We have did similar question in the last basic example 4. In basic example 4, what if you remember, their temperature is what? 250 degrees Celsius, and 250 degrees Celsius it is easily available in the proper table. But if you observe here guys, in this question, what is here we have? What temperature we have? 260 degrees Celsius. And if you go to the 260 degrees Celsius of the superheated for the 0.5 bar superheated guys. See this one. For the 0.5 bar 260 degrees Celsius table is not available guys. For the 0.5 bar it will start from 100, 150, 200, 250, 300, 400, 500. But 260 is not available. And here comes the role of the interpolation guys. And now tell me, this 260 degrees Celsius available between which temperature guys? It is available, it is in between what? 250 and 300 degrees Celsius. So what we are going to do? We are going to do what? We are going to form a table guys. And how we are going to form a table? We need two things guys. We need the enthalpy and entropy. So we are going to include all these two things only in one table. So first column of the table is what? Temperature. Temperature will be in what? Degrees Celsius. Second column of the table is what? Enthalpy. Enthalpy is in what? Kilojoule per kg. Third column is what? Entropy. Entropy is in what? Kilojoule per kg Kelvin. And for this one guys, everyone, which temperature we have? Temperature of 260 degrees Celsius. This 260 degrees Celsius, this temperature of 260 degrees Celsius guys, this temperature of 260 degrees Celsius, this is what we have to find out. This 260 in the proper table lies between what? This 260 degrees Celsius lies between which two temperature guys? Everyone tell me. It is lies between 250 and 300. It lies between which two temperature guys? Everyone? 250 and 300. So this is what? 250. And here we have what? 300 degrees Celsius. So we can take it as a what? We can consider it as what? Our x1. Guys observe. we can consider it is what? Our x1. This is what? A x. And x2 means our x is lies between what? X1 and x2 guys. That is 260 degrees Celsius. Observe. This is, I'm writing for our understanding. In exam we are not going to write down like this. This is for the sole purpose of our understanding guys. 1 minute, let me complete the table properly. Now tell me guys, at what pressure we are forming this table? So at the top of the table we are always going to write down what? At the top of the table we are going to write down the pressure of the table. This table we are particularly forming at what pressure guys? Everyone? At P is equal to what pressure? Can anyone tell me? What pressure we are forming? At a pressure of what? 0.5 bar pressure that we are forming this table. So now observe the scenario here guys. Very simple discussion. The corresponding value of H. For the tube, this value of H we have to find out. This value of H, what we have to find out guys? This value of H we have to find out. So for this 250 degrees Celsius guys, everyone observe. For this 250 degrees Celsius, what is the value of H we have guys? Everyone, we will go to the property table. 250 degrees Celsius, value of H for the 0.5 bar. This is H, 2976. So I am writing down 2976. And for the 300 degrees Celsius, or 0.5 bar, 300 degrees Celsius guys, observe 3076 guys. So if our temperature lies between 260 degrees Celsius lies between 250 and 300, then corresponding enthalpies also lies between these two enthalpies guys. Getting my point? And this is what we can say. This is what our y1, this is what a y, and this is what a y2 guys. And here we will use a by interpolation guys. Observe. See, every time no need to write down this interpolation guys, as it is a basic numerical, and we are, some of you maybe with rating background, for them we need this discussion guys, and it is always to have a good this discussion. So what is relation interpolation? Y minus y1 divided by what? X minus x1 is equal to what we can say? Y2 minus y1 divided by what? X2 minus x1. So what is the value of y? That is unknown to us H. We need what? H. Y1 2976 divided by what guys? Everyone, divided by what? X is how much? 260 minus X. This is X1 guys. And X1 250. Y2 minus Y1 guys, everyone. Y2 minus Y1 3076 minus 2976. Observe. Divided by what? 300 minus what? 250. And if you do the calculation guys, we need a value of what? We need a value of enthalpy guys. Everyone, do the calculation and tell me the value of enthalpy. Try to use a shortcut. In calculator, in place of H, you can put a substitute X and then everyone try to do the calculation guys. If you do the calculation guys, the value of H that we are getting 2996 kilojoule per kg. Okay, so in this way we can use the word guys? Interpolation. Very simple discussion guys, not that much difficult discussion. Now then what is the next thing? Entropy guys. So we need this entropy. For 250 degrees Celsius value of entropy is how much? For 250 degrees Celsius value of entropy, this 250 degrees Celsius guys, value of entropy is what? 8.355. 8.355. So I will write down 8. See this one guys and check it. 8.4.5 bar. So 8.355, check it. 8.355. I'm going to write down this 8.355. Then for the 300 degrees Celsius value of entropy, how much? For 300 degrees Celsius 4.5 bar, 8.537. This value guys, check it. Yes. And 300 degrees Celsius 8.537. 8.537. And for us this is what? A y1, y and y2. And we have seen the relation of interpolation guys. y minus y1 divided by what? X minus x1 is equal to what? y2 minus y1, x2 minus x1. X is the same because temperature is the same. So here what we can say? y1 8 point. So we need a s. So s will become our y. y1 8.355. y1 is how much? 8.355 divided by what? X minus x1, that is what? 260 minus 250 equal to what? y2. y2 will be what? 8.537. 8.537 minus what, guys? 8.355. 8.355 divided by what? X2 minus x1, and that is what? 300 minus 250. So 300 minus 250, and if you solve this one, we will get a value of entropy at 260 degrees Celsius and 0.5 bar pressure. So please everyone, do the calculation with me. So if you do the calculation, guys, what is the value you are getting? Entropy value, everyone? 8.3914. 8.3914 unit kilojoule per kg Kelvin, guys. So in this way, what we got it, guys? We got the value of entropy and enthalpy at a pressure 0.5 bar and temperature 260 degrees Celsius. And here interpolation is useful for us. We have already written these things. Then after that, guys, everyone start writing down this discussion, everyone. Now after this, guys, write down this discussion of the entropy. Now everyone, you the next heading, basic example C 6, and try to write down this question, guys. Everyone, try to write down this question, and after writing of the question, please read this question minimum 2 times, everyone. Now in this question, guys, what they are asking us? First of all, they are asking us a state. For the pressure of H2O is how much? 5 bar. And here they have given us what? Enthalpy of what? 2890 kilojoule per kg of enthalpy, guys. So here, before going further, we are going to write down the given things, guys. What they are given us. So pressure is how much? 5 bar. Everyone, how much pressure we have? 5 bar. And enthalpy is how much? 2890 kilojoule per kg. And see the scenario here, guys. Observe. So our first target is what? We have to find out the state. And if you see the scenario here, so whenever we have a pressure and its enthalpy, what we are going to do? We will go to the property table and we are going to find out HF at 5 bar and Hg at 5 bar, guys. Everyone go to the property table and first of all try to get the value of HF and Hg by yourself, guys. Everyone, before going further, try to get the value of HF and Hg at 5 bar by yourself, guys. Everyone. So if you see HF and Hg at 5 bar, how much HF and Hg at 5 bar, guys? Everyone, observe HF and Hg at 5 bar. If you observe HF and Hg at 5 bar, now what we are getting? 5 bar, guys. We need a 5 bar pressure. So up to this point, it is a, so HF and Hg at 5 bar, we will go to this one, this pressure one, and 5 bar, guys. 5 bar, here we have a 5 bar. This is what our 5 bar, guys. And HF and Hg, HF 640 and Hg 2749 for the 5 bar. 640 HF 640 kilojoule per kg, and Hg how much we are getting, guys? Everyone, Hg, guys, this is Hg 2749 unit kilojoule per kg. And just compare the given Hg that is given to us. This 2890, check it, is it lies between these two value? Is this 2890, is it lies between these two value? If it is lies between these two value, then state is what? Saturated wet vapor, guys. Now we have seen one numerical. In that, if you remember our example 2, our enthalpy in example 2, guys, basic example 2, enthalpy 2 is 2060, lies between this HF and Hg, guys. So that's why our state of H2 is what? Wet vapor. But in this question, guys, everyone, in this question, tell me, this value of H lies between these two? No, it is higher than this one. And whenever enthalpy is what? Greater than the Hg, guys, what is the state? Can anyone help me? We have studied this one, guys. Since value of H is greater than the Hg, the state of H2O will be what, guys, everyone? The state of H2O is what? See this one, superheated conditions, guys. If you remember superheated vapor condition, so enthalpy is greater than the what? Hg, for the superheated vapor. So if H is greater than the Hg, the state of H2O is what? The state of H2O is what? Superheated vapor. What is the state of H2O, guys, everyone? State of H2O is what? Superheated vapor. So before going further, please everyone write down this discussion. Now after that, what we have to find out? Temperature and entropy. And that is the main purpose of this question, guys. See, this is the entropy is the simple part. How to get a temperature and entropy for this situation. And for that purpose, we are going to use a interpolation, guys. So now tell me, here, what is pressure we have, guys, everyone? What is the pressure? Here we have pressure of 5 bar. So what we are going to do? We are going to form a table at a what pressure? P is equal to what? 5 bar. And that table consists of total 3 part, guys, everyone. Table consists of total 3 part. First part is what? Enthalpy. Enthalpy is in what? Kilojoule per kg Kelvin. Then we have to find out temperature. Temperature is in degree Celsius. And then we have to find out entropy. Entropy is in what, guys, everyone? Entropy will be in what? Kilojoule per kg Kelvin, guys. So this is the table. This table consists of total 3 part. Very simple discussion, guys. I'm going to complete this table for us. Observe, guys, don't write anything. Just listen my words carefully and try to understand each and every point, guys. Understanding this. See, which enthalpy we have, guys, everyone? How much value of enthalpy we have? How much value of enthalpy we have, guys? The value of H, which is to us. Value of H, which is to us, is how much, guys, everyone? In the question, value of H, 2890. So here I am going to write down 2890. Corresponding temperature we have to find out. Corresponding entropy we have to find out, guys. And so we can say it as what? Our X, this is what? Our Y, and this is also what? Our Y. And this, see, we will go to this, always remember this, here we have to deal with pressure, guys. So we will go to the 5 bar pressure. Everyone, what we will go? 5 bar to what? Superheated one, guys. 5 bar to what? Superheated one. These things are little bit now confusing. So my suggestion is what? Try to solve this numerical after this one 2 times, guys, by yourself. So see, 5 bar, we need a what? Value of H. What is the value of H we have, guys? Everyone tell me. 2890. So value of H is what? 2890. Just observe. I'm a little bit zooming. Okay. So value of H 2890. Now tell me this 2890. These are the different values of H. 2857, 2962, 3065, 3168. So this 2890 lies between two values. Which two values of H? This 2890 lies between which one? 2857. Okay. These two values must be adjacent to each other, guys. 2857 and 2962. 2857 28 what guys everyone? 2857 and 2962. I'm checking once again. 2857 for 5 bar guys. 2857 and 2962. 2857 2962. 2857 2962 and corresponding temperature to 2857. Tell me guys. Corresponding to 2857 corresponding temperature is what? 200 degrees Celsius. So temperature is what? 200 degrees Celsius. 2962 corresponding temperature is what? 2962 corresponding temperature 2962. 250 corresponding temperature 250 means this can be our Y1 and this can be our Y2. Guys, simple discussion. Then corresponding to, and here what we can say, this can be our X1 and this can be our X2, and if you do the interpolation with the help of these values, we will get the values of temperature. See, earlier previous question, with the help of temperature we got enthalpy and entropy, but here with the help of enthalpy we can get a what? Temperature and entropy guys. Very simple discussion, not that much difficult. So here, and see, we need entropy also, so we will write down here only entropy values. 2857 corresponding value of entropy 2857 guys. 2857 7.06, this one 7.06, so I am going to write down this 7.06. they written 0 also, but that is negligible, that is not important. And then 2962 7.271 7.271 7.271. So this will be value of Y1, this one Y1, and this will be value of what guys? Y2. And try to see the scenario here. Very simple discussion, not that much difficult discussion. So in this way we form the table, and now we will use our favorite relation of interpolation guys. And what is the favorite relation? Delta Y by delta X guys. So Y minus Y1, see this is favorite relation, Y minus Y1 divided by what? X minus X1 is equal to what? Y2 minus Y1 divided by what? X2 minus X1. Observe the scenario here. Y is how much? Temperature. Because first of all we are going to calculate temperature. Then Y1 200, X 2890, X1 2857 is equal to what? Y2. This is Y2, 250 for the temperature. Y1 200, X2 2962, X1 2857. And if you solve this one guys, we will get the value of what? Temperature guys. Everyone try to solve this one and try to get the value of temperature. Everyone try to solve this one by yourself and try to get the value of temperature. In place of temperature, you are going to put a X in your calculator and use a shift solve. You will get the value of X guys. So if you do the calculation guys, the value of temperature that we will get 215.7142 guys. 0.71 we will say 43 degrees Celsius. In this way we will get a what? Value of temperature. So in this way what we got it guys? Everyone, we got the value of temperature. And similarly we can get the value of what? Entropy guys. Here I will write down the discussion of the entropy. So here I am going to write down these things side by side, so that all the things properly available to us guys. So here we got the value of temperature. Similarly we can calculate what? Value of what? Entropy. Same relation. Y minus Y1 divided by what? X minus X1 is equal to what? Y2 minus Y1 divided by what? X2 minus X1. Y is how much? Entropy that we have to find out. Y1 7.06. X is how much, guys? This is 2890 minus X1 2857 is equal to what? Y2 7 point 7 point what, guys, everyone? 7.271 minus 7.06 divided by 2962 minus 2857, and do the calculation and tell me the value of entropy, guys. So please everyone do the calculation and tell me the value of entropy. And if you do the calculation, guys, we will get the value of entropy is what? 7.1263 unit kilojoule per kg Kelvin, guys. So in this way we got the value of what? Temperature and entropy, guys. So we have already written this discussion, guys, up to this one, state of H2O. If you have not written, write down this one, guys, and then please complete this discussion, guys, everyone.